Hello, I'm Arthur. Welcome to my lab. Space in my lab is kind of tight because I have so many projects going on that I'm just running out of space. And this is my video editing laptop with the monitor attached to it. That is just nicer to use because it's a bigger screen, so it's nicer to use to edit videos. But of course, in this arrangement, it's not going to work very well with the monitor sitting behind the laptop. And I could just put the monitor on top of some box just to elevate it. But I always wanted to have a monitor like this sitting on some sort of a rail so that it can slide up and down as my needs change. Maybe I will need to put something on this desk to work on something, and then I'll need the monitor out of the way. So I thought about doing something like that, somehow being able to lift this monitor and just keep it installed in some fashion. I remembered that I have these two metal rods that I used on another project, and then I discontinued that and didn't need them anymore, so they were just sitting around. So I thought that these would make an excellent slide. So I had to design parts for the rest of the mechanism, the rest of the slide, and here they are. These are the plastic parts that you'll need to build this slide. This is 80mm M8 bolt and a nylock screw for it, and this is a 50mm M8 bolt with also a nylock, two 15mm M3 screws with nylocks, some screws to mount the whole thing to the wall, and some basic tools. So this is all that's needed, and here's how you can assemble it. You take this main slider, and these locks have an offset. I don't know if you can see it. This center hole is offset to the side. The idea is that once you put it in, as the rod tries to slide up, or this part tries to slide down due to gravity, the offset here will be pulling this lock to the more locked position. The friction here will be pulling this lock in, this arm in, and that will lock even tighter, so that should prevent this part from sliding down. Of course, the concern is that if there's not enough friction between the rods and this piece, then this won't work. I may put some rubbery substance, like maybe rubber cement or some other kind of glue that's kind of sticky rubbery. I may put that on this surface so that it locks better. But that's how this part will work. And I'm using just a regular M3 screw like that with a socket cap. You can use Phillips head or whatever you have, but that's what I like to use. This screw goes in from the back, and of course you have to fiddle a little bit with it, and then the nylock goes on the screw. Hold it with pliers. Tighten just enough so that the nylock engages and this whole thing doesn't move, but the arm should still swivel. So see, this is tight now, but the arm still swivels freely. You don't want to over tighten that. Here's the other side, same deal. There we go. And the reason why these screws go from this side in is because of the clearance between this part and the wall. You don't want the other side of the screw sticking out too far and maybe hitting the wall. Okay, nice and tight, and this is still loose. And then we slide the rods in, and this should be printed fairly snug, fairly tight, So it should be a good tight fit in here. And you can drill out these holes if they are too tight. And then, so the bottom cap goes on these rods like so. And of course, make sure that both rods are all the way in. And then the top cap goes on the other side. And this should go on the rods fairly easily. There's enough clearance on them. So don't try to hold it by, by this piece, because the rods will come out. Now the next part, and you can see that I'm using different colors of plastic. That was because I was using up some old plastic. So these arms should be on the top, and then this swivel will pivot here, and the bolt needs to go from the top, so that even if you lose the nut on it, the bolt will not fall out. If it was upside down, it would fall out and bad things would happen to your monitor. So the bolt goes from the top, and then again tighten this, and this time you want this pivot to be fairly tight. You want it fairly tight so that once you pivot the monitor, it stays here and doesn't swing back and forth. So just play with the tightness. Make sure that it's fairly tight. And this is the arm that goes on top. And actually, I kind of designed this part wrong. This part here is a little too high, and it hits on these parts here, so it actually prevents it from pivoting. But in a way, that's good. I'm going to keep it like that for now, because basically this will prevent the motor from swinging down on its own. And I'll print another part that will pivot if I want to, if I need to, but I'll see how this works to begin with. And I will probably post both parts so that you can choose whichever one you want. If you go with this part that I'm using now, then basically your monitor will only pivot sideways and not up and down, which actually may be a good thing. And again, make sure that this is tight. And that's it. That's the assembled part. And these holes are 100mm spacing. That's one of the typical sizes for monitors. There's 50 by 50, 100 by 100, 200 by 200, and there's some fractional like 100 by 50 or something like that. So you may need a different bracket, and I will post several different sizes so you can match whatever your monitor size is. And that's it for the assembly. So these locks, they don't have to go all the way down, so don't force them. They need to just go as far as they have to be tight, and hopefully this whole slide will not move. But if you open them, the slide should move. And still, this is fairly tight right now, so even with the unlock mechanism, there's some friction. But once I lock them, see, I'm pulling pretty hard on this and it doesn't move. So that looks good. And then the last parts are these bolts, which will go through the mount points here and attach this thing to the wall. So let's see how that works out with this unit mounted on the wall and the monitor mounted to it. I forgot about one more thing that you'll need for this. Of course, this bracket needs to attach to the back of the monitor, and some monitors come with these bolts, but if they don't, then for 100 by 100 size, the size of the screws is M4. For some bigger monitors it will be M5, but for 100 by 100 and anything smaller, it should be M4. And these are 16mm screws that I'm using here. They will go in through here. This is about the right length. Try to use as short screws as possible so that you don't screw into something in the inside of the monitor, but long enough so that the whole thing is secure. And you can even use spring washers. Put a spring washer here and then stick it through, so that will secure the screw even better. I should probably do this, but I don't have spring washers, so I'll just work with this, and then maybe I'll get spring washers later on and install them. Turns out that the monitor is sitting right between the two studs in the wall, so I can't use these drywall screws because they need to go in the studs. So I'm going to use these pins instead, and the screws that go in them. So I'll just use these anchors, and just make sure that you use the anchors that are rated for the weight of your monitor. Most monitors are fairly light, so that shouldn't be a problem, and any anchor should do that fits the holes in the plastic pieces. And I'm sure that these 4 anchors put together will have a lot more capacity than the weight of my monitor, so that should be all fine. And here it is, my monitor hanging above the laptop now. Here's the upper part sticking up above the monitor, so I can slide it up much higher. And I still have some clearance below the monitor, so I can slide it lower if I need to. And it worked out perfectly.